Hello, it's me, Maria Sandoval, again. Today I'm going to be presenting the atomic symbol, number, and mass. So here's the X, and we're going to be starting off with that. So X is our atomic symbol. So here you see it's O, that means that it's an atom of oxygen. Here it's C, so it's an atom of carbon. So whatever 1 to 2 letters are on it on the periodic table are what is going to be there for the atomic symbol. A is your mass number. You see here it's at the top, so it's your protons plus your number of neutrons. Also, A equals Z plus N, which we're getting to just here. Z is your atomic number, which is the bottom here, which is your number of protons, and then N is your number of neutrons. So once again, it's your number of protons and neutrons. You're gonna add them together to get this. Moving on, we're talking about isotopes. Isotopes are atoms of an element with the same number of protons but a different number of neutrons. So they're kind of like siblings. They're almost the same, but genetically chemically there's differences. So isotopes have the same atomic number but a different mass number. So their atomic number is always going to stay the same. And that's how you know what element it is on the periodic table. But the numbers of neutrons, the numbers of neutrons can change. So here you see this one has 146, but this one has 143. So that means when you add these numbers up, they're different, and that's why you get different mass numbers on top. So that's how you can see that it is an isotope. And it is a different kind of the same atom. Here we're determining the number of subatomic particles in the isotopes of an element. So we're going to look at a few isotopes and we're going to try to decide or find out how many protons, neutrons, and electrons it has so that you can find out what the difference is between them. So silicon has 3 naturally occurring isotopes. These happen out in nature. So 28 silicon, 29 silicon, and 30 silicon are these naturally occurring isotopes. We want you to determine the number of protons, neutrons, and electrons in each silicon isotope. So plan. The mass number A is given for each isotope and is equal to the number of protons and neutrons. The atomic number Z found on the periodic table equals the number of protons. The number of neutrons equals A minus Z. The number of electrons equals the number of protons for a neutral atom. So, what you're going to want to do is figure out what the periodic table base is. So how many it should have as protons, because protons are always going to stay the same. So you figure out, here in silicon it has 14. So whatever number you have up to the left is going to be minused by your protons, and you will find out how many neutrons you have, because that's your protons plus neutrons. That's how you find out that number. So you just subtract it and you will find out how many neutrons and protons you have. The electrons also stay the same. So it's pretty interesting that you can just find out what the difference is by doing simple math. Here it's showing how you can form an isotope. So here's a formation of a charged neon particle, which is positive. So here you see a high energy electron collide. So this here is your high energy electron and it's hitting your neon particle. It collides with the neon particle. And then your source of energy of high energy electrons, I'm assuming this is being reproduced in a lab, so they have something like that. An electron is lost when this happens. So we lose a negative charge, leading to a overall positive charge, because as you can see, we have lost an electron through that high charged another high charged electron colliding with it, leading us to have a positive charge. And this is a positive isotope because there are more protons than electrons. This is showing a scientific tool that you use in the laboratory, and this is basically doing what I just showed you before and forcing it to happen. So here's that electron source. Remember, it's high energy and it needs to hit the electrons of that neon particle so that it can lose the electron, giving us the positive charge. So here the sample enters the chamber and it's vaporized. The electron beam, which is our high energy electron, knocks the electrons from the neutron atom, or from the neon atom. My bad. And then the electric field accelerates the particles towards the magnetic region. So here's the charged particle beam. It does the same, the lightest particles and the heaviest particles, and we end up with our isotopes. And here are some readings on them. You see this plus. So we have a positive charge to our isotope because we've lost an electron. That is all for today. Thank you so much. I've learned a lot, and I hope you have learned